Welcome to Summarize Science, where we look at how tiny tech is solving huge space problems. Did you know that most small satellites, called CubeSats, collect way more data than they can actually send back to Earth? This paper explores how TinyML can make these miniature satellites much smarter by processing images right on board. Traditionally, satellites must send raw images to ground stations for analysis, but this is often too slow and power-hungry for tiny systems. The researchers propose a major paradigm shift. Instead of moving all that data to the ground, they want to bring the computation directly to the data. By using artificial intelligence directly on the satellite, it can autonomously filter out things like cloudy images, which can save up to 30% of downlink data. The team used a specialized microcontroller called the STM32N6, which is designed to handle AI tasks with very little power consumption. Because space is a harsh and limited environment for electronics, these systems must fit within incredibly tight energy and memory budgets. To make this work, the researchers developed a three-step pipeline to systematically shrink heavy AI models into something that fits on a tiny chip. First, they used a technique called pruning, which identifies and removes unnecessary parts of the neural network without losing significant accuracy. Next, they applied quantization, which converts complex mathematical data into a much simpler 8-bit format that is easier for the chip to process. Finally, they mapped these operations specifically to the satellite's internal hardware to maximize both speed and efficiency. The results were impressive, showing an average reduction in RAM usage of nearly 90% and a 70% reduction in flash memory storage. Even with these massive cuts, the AI models remained highly accurate across different sets of satellite imagery, like land cover and disaster assessment. The researchers found that in some cases, the pruning process even helped the AI focus on more robust features, which improved its performance. In terms of energy, the system is so efficient it uses only a few millijoules of power per image analysis. The processing is also lightning fast, completing a complex image classification in as little as 3.2 milliseconds. By only sending back the images that the AI is uncertain about, the researchers demonstrated a way to reduce total data traffic by over 85%. In summary, this TinyML approach allows CubeSats to act like miniature brains in orbit rather than just simple cameras. The researchers proved that even ultra-constrained hardware can handle advanced AI tasks for Earth observation missions. This could lead to much faster disaster response times and more efficient global monitoring using fleets of cheap, tiny satellites. It marks a significant step toward a new era where intelligence is distributed throughout our entire orbital infrastructure. Thank you for watching Summarize Science.